Hello friends, I welcome you in lecture number 17 on Laplace transform. In this lecture we will discuss the formula for Laplace transform of the derivative of a function. So we will see how to find out Laplace transform of a derivative of a function. So for that we assume that function is differentiable. So first we write down that suppose that our function say f of t is differentiable for all t greater than or equal to 0, and we assume that Laplace transform of f of t and its derivative exist. Then there is one result which gives us the formula for Laplace transform of f dash t. We are not proving this result, we will assume this result, and whenever it is required we will use this result. So we will remember Laplace transform of derivative of a function is equal to s times Laplace transform of f of t minus value of function f of t at t equal to 0. And if we use the notation, suppose we use this notation for Laplace transform of f of t, it is denoted by say f bar of s, then this is equal to s times f bar of s minus f of 0. So we will remember Laplace transform of derivative of f of t is given by s times f bar s minus f of 0, where f bar s is nothing but Laplace transform of f of t. So we will require this formula whenever we will discuss initial value problems, solution of initial value problems using Laplace transform. So we will require this formula at that time. Now using this formula we can derive the Laplace transform of second derivative also. Suppose I want to write down the formula for Laplace transform of second derivative, then this is equal to Laplace transform s times, or this we can rewrite as d by dt of f dash t, okay, because we have second derivative. So instead of this, here we are using f of t s into Laplace transform of f of t minus f of 0. So here if we have f dash t, if we have derivative of f, then this is equal to s times Laplace transform of f of t minus f of 0. So here we have derivative of f dash. So in this formula this f of t will be replaced by f dash t, or we can assume that suppose f dash t is some another function, say g of t, where g of t equal to first derivative of f. So this we can rewrite as Laplace transform of g dash t, and now we use this formula for Laplace transform of g dash t. So that is going to be s times g bar s minus f of 0. So this is equal to s times g bar s, or Laplace transform of function g minus value of function g at t equal to 0. Now we substitute value of g of t. G of t is nothing but f dash t. So here we write, instead of g of 0 we will write f dash 0, okay, because we have used f dash t equal to g of t. Now we are putting g of t equal to f dash t here. Now this is equal to, now we have the formula for a Laplace transform of f dash t. So we again replace Laplace transform of f dash t by s into Laplace transform of f, which we have denoted by f bar, minus f of 0 minus f dash 0, and if we multiply this bracket by s, we will have s square times f bar s minus s times value of f at t equal to 0 minus f dash at 0. So this is Laplace transform of second derivative of function f of t. So we can understand the pattern. If we have Laplace transform of f dash, then Laplace transform of f dash t is s into f bar s minus f of 0. So if we have first derivative, we have first power of s multiplied with f bar s, and then power of s is decreasing. So in the next term, power of s is 0, that is 1. Similarly, here we are having second order derivative. So f bar s is multiplied by s square, then power of s is reduced by 1. So here power of s is 2. Here we write power of s 1 into value of function at t equal to 0 minus power of s is again decreased by 1. So that is s raised to 0, which is 1. And here we have f of 0, that is no derivative, 0 derivative, and here we have first derivative. So here order of derivative is increasing, f of 0 then f dash 0. So from this we can generalize this for higher order derivative. Suppose I want to write down formula for Laplace transform of third derivative of f of t. Then if I have second derivative, I start with s square. Here I will start with s cube into Laplace transform of f, which we have denoted by f bar. Now I am decreasing power of s. So s square, I will start with value of function at 0, that is 0 order derivative of f at 0. Then again decrease the power of s. Then here there is no derivative or 0 derivative, and we have to increase the order of derivative. So 0 derivative, then first derivative, then power of s is decreased. Here we have s raised to 1. So in the next term we have s raised to 0, that is 1. Here we have first derivative at 0. So in the next term we will write second derivative at 0, and we stop here. If we have Laplace transform of second derivative, last term is first derivative at 0. So if we have Laplace transform of third derivative, we will stop when we write second derivative at 0. So we can generalize this for Laplace transform of any derivative of any order. Suppose we want to write down the formula for Laplace transform of nth derivative, then we will start with nth power of s is multiplied with Laplace transform of s minus decrease the power of s raised to n minus 1. Start with value of f at 0, then again decrease the power of s raised to n minus 2, then first derivative at 0, next term is s raised to n minus 3, second derivative at 0, and so on. We can write one more step, s raised to n minus 4, third derivative at 0, and this will continue, and so on. If we have third derivative, last term is second derivative at 0. If we have nth derivative, last term is n minus 1th derivative at t equal to 0. And here f bar s is the notation for Laplace transform of f of t. So in this way we can find out Laplace transform of nth order derivative of a. So we will remember this formula, and this formula will be used in solving differential equations with initial conditions, or in solving initial value problems using Laplace transform. So for that we have to first discuss inverse Laplace transform, and then we will go for initial value problems, and at that time we will require this formula, Laplace transform of the derivative of a function. sometimes they ask you to write down the formula for Laplace transform of derivative of a function. So you should remember this formula, and here you should write that suppose our function is differentiable n times, and suppose Laplace transform of f exists, then Laplace transform of nth order derivative of f is given by s raised to n times f bar s, which is Laplace transform of f of t, minus s raised to n minus 1 value of function f at t equal to 0, minus s raised to n minus 2 first derivative at t equal to 0, minus s raised to n minus 3 second derivative at t equal to 0, and so on. Last term is n minus 1th derivative of f at t equal to 0. So first term is s raised to n into f bar s, and then all the terms are having negative sign, power of s is decreasing, and order of derivative at t equal to 0 is increasing. And if we have nth order derivative, last term will be n minus 1th derivative of f at t equal to 0. So remember this formula. We will need this formula in solving initial value problems using Laplace transform. So this is all about this session. I hope you like it. Thank you very much.